Hi, I'm David.
And I'm Hannah.
And we're scientists who study the physics of the sun at the University of Newcastle in Australia. That means we want to understand how the sun works.
And we do this by looking at photographs of the sun and using some maths. We also teach physics at the university, which is the branch of science that tries to understand how things in the universe behave.
So I'm originally from Scotland, which is in the United Kingdom, and I started my studies there at the University of St Andrews. Once I got my PhD there, I got a position doing research at the University of Waikato, which is in Hamilton in New Zealand. And after that, I moved to New Hampshire in the United States, again as a research scientist position. After that, I went back to Scotland and I worked at a university there for a few years. And then in 2019, I moved to Australia, to Newcastle, to work at the University of Newcastle here.
I grew up in Adelaide, Australia, where I went to the University of Adelaide and studied science. I then moved to Melbourne to do my PhD at Monash University before moving all the way to Germany to research the sun. More recently, I've moved back to Newcastle, where I'm now working at the University of Newcastle, continuing my research, but also teaching. So as you can see, as scientists, we work together with other scientists all over the world.
So why is it important to understand how the sun works? Well, did you know that just like there's weather on Earth, there's also weather in space?
Explosions on the sun cause storms in space, and when they reach Earth, they cause these beautiful lights in the sky. But they can also damage satellites and interrupt phone signals and GPS.
Alright, we need to know about the sun, so let's start with some basics. First of all, how big is the sun? Well, it's really difficult to get an idea of that because the numbers are so enormous. So we're going to try instead to make a little model. So I've got a golf ball here, which is going to represent in our model the Earth. And for this to be a good model, we need everything to be shrunk by the same amount. And so I've got, you could maybe see here, this little Lego head, and that's going to be the moon. And so in our model, the Earth and the moon are something like this distance apart. So now we're going to try and figure out, for our model, with everything shrunk by the same amount, how big is the sun? So in our model, do you think that the sun is a basketball? Or is it a space hopper? Or is it an African elephant? That's right, it's actually the elephant. So next question. How far away do we think that the sun is? Again, the number is an enormous number and it's hard to get your head around, so let's try and figure this out in our model. So the Earth and the moon in our model are roughly this far apart. So where do we think that our elephant has to be in order to make this a good model? So here's an Olympic swimming pool, which is 50 meters long, and here's our elephant. So the question is, for our model, should that elephant be halfway down the swimming pool? Should it be at the far end of the swimming pool? Or should it actually be 10 Olympic swimming pools away? Well, it turns out that the elephant's actually 10 Olympic swimming pools away. So this is a really large distance if we remember that the Earth in our model is just the size of a golf ball.
So we know the sun is really, really big, and we know it's really, really far away. And we can't look directly at the sun, so how do we actually see it? This is a photo of what we call an eclipse. This is when the moon passes between the sun and the Earth, and we can see the atmosphere of the sun because most of the bright light is blocked out by the moon. So eclipses only happen occasionally, but we can make instruments that can block out the brightest part of the sun so we can see what's happening in the outer atmosphere. And what you see here are these huge explosions that send giant bubbles of hot plasma into the solar system. So another way we can look at the sun is to put a telescope into space. And these special telescopes only look at a small part of the light. So the sun is not so bright and we can actually look at the surface of the sun. And this is what we see when we look in only a small part of the light and can see the surface of the sun. Now watch the lower left part of the screen. Did you see that fast loop breaking and all of the beautiful loops created? That's the beginning of an explosion on the surface of the sun. And these loops are constantly changing and recreating. Just like the magnets on your fridge cause these patterns in these iron filings, the sun's magnetic field creates these loops in the atmosphere.
Now, the sun's magnetic field is constantly changing, and this sometimes leads to these enormous eruptions, as we see in this movie. Now, up in the top corner, you can see the Earth there to scale, and so we see the gigantic size of these explosions. So we don't know why these explosions happen, and we don't know when they're going to happen. And the reason that we'd really like to know that, we can see from this cartoon animation now, which shows what happens when one of these explosions occurs. It creates a hot bubble of plasma which gets shot out at 1,000,000 miles an hour across the solar system and can come into contact with the region around the Earth. Now, fortunately, the Earth has a magnetic shield, which is shown by these purple lines, which protects us from the most harmful effects of this storm. But the way that the Earth's magnetic field responds creates these spectacular northern and southern lights. So when these solar storms reach the area around the Earth, they can have quite damaging effects. So they can damage our satellites, they can disrupt our phone and GPS signals, and they can also be very dangerous to astronauts. So we'd really like to be able to predict when these storms are going to occur, or we'd like to be able to have a forecast then for the weather in space, just like we have a forecast for the weather on Earth. So my research is all about understanding how the sun's atmosphere behaves, why it behaves the way it does, including how these eruptions occur.
And we know that these eruptions are caused by the sun's magnetic field, and the magnetic field comes from the inside of the sun. So I'm interested in looking inside of the sun and knowing where the magnetic field comes from. So you've learnt a lot about the sun in the past few minutes. You know how big the sun is, you know how far away the sun is, and you know the different ways we can look at the sun in different parts of the light. So imagine you're an astronaut in the future traveling to Mars. How would your spaceship protect you from space storms? Maybe you can talk to your teachers about this, or your friends, and you can look up information on the internet.
We hope you enjoyed this short introduction to our sun.